Okay, let's look at question 28. So we have, for t is greater than or equal to 0, the position of a particle moving along the x-axis is given by this function. What is the acceleration of the particle at the point where the velocity is first equal to 0? Okay, so if we take the derivative of our position function, that is going to be equal to our velocity function. So let me go ahead and derive both sides with respect to t. So whenever I do that, I will get the velocity at time t is going to be equal to cosine t plus sine t. Now we want to figure out where is the velocity first equal to 0 so we can get that point that we can plug into the acceleration. So I will set my velocity equal to 0, and then I will have to solve for t. Now the key here is to recognize that I need some value of t that will give me basically the same value of cosine and sine, but with differing signs so that they cancel out. So if you'll recall the unit circle, and I'll just go ahead and draw it out here again, but we have a few points that are of particular interest. So we have pi over 6, pi over 4, and then pi over 3. Now, if you remember, for our pi over 4, we are going to get this, how do I say this? The coordinates are going to be root 2 over 2, and then root 2 over 2. Now, if I go over to this side, and I look at this one right here, well, the angle, or again, I'll say that theta is equal to t, right? Because as time goes on, we're going around this unit circle, right? So whenever t equals negative pi over 4, and it's on this side, well, what I'm going to have is I'm going to have a negative root 2 over 2, and then a positive root 2 over 2. So what does this mean? Well, basically this means that whenever t equals negative pi over 4, what I'm going to get whenever I plug that in is I'm going to get negative root 2 over 2, and then I'm going to have a positive root 2 over 2, and they are going to cancel out, and I'll be left with 0 equals 0, which checks out. And basically, I know that this has to be the first point that this happens because as t increases, I go around the unit circle counterclockwise, just like you would for theta. So what that means is that the point of interest is going to be occurring when t, or how should I say this? I'll say that v of 0, no, I'm sorry. The point of interest is going to be, let's see, how do I write that out? V of negative pi over 4 is going to be equal to 0. Okay, so that is our point of interest. Now, what I have to do is I want the acceleration at that time t pi equals negative pi over 4. Or sorry, t equals negative pi over 4. So I'm going to derive both sides with respect to t again now. So I will have the derivative of the velocity function, and then I'll take the derivative of that function itself. And again, the derivative of velocity is just going to be acceleration, so I will have my acceleration at time t is going to be equal to negative sine t plus cosine t. Now, whenever I plug in this negative pi over 4 here, what I'm going to get is that a of negative pi over 4, well, that is just going to be equal to negative, and then again, sine of that value, which is just going to be root 2 over 2, and then I will have plus the that cosine function, which is going to be negative, let's see here, negative root 2 over 2. So whenever I fully simplify this down, I'm going to have that a at that, the acceleration at that point is going to be equal to negative root 2, because I have a half plus a half is just the whole. So therefore, my final answer is going to be negative root 2, or in this case, it's going to be answer choice A, and that is in fact the correct answer. So guys, you have to use kind of some conceptual reasoning here, but hopefully, you know, it makes sense after watching the video. If you have any questions, please feel free to comment below, and I'll see you in the next video.